Lambda phage, a virus consisting of a capsid and a 49 kb of double-strand DNA genome with two cosides. The extraordinary efficiency of this capsid to transfer DNA to the bacteria tempted scientists to use it as a vector. But there is a big limitation. The lambda capsid just accepts DNA with size between 35 to 53 kilobase with cosides. So if we want to use intact lambda phage as a vector, we just transfer 3 to 4 kb of DNA. But the solution is removing approximately 10 kb of unnecessary DNA of lambda phage for lytic cycle. Through this modification, we can transfer up to 10 kb of target DNA with this vector named insertional vector. An insertional vector in both recombinant and non-recombinant type could insert to the capsid because of its legal size limitation. In the next step, we removed more of lambda phage DNA and increased the capacity of transferring up to 23 kb of DNA. The yielded vector named replacement vector in recombinant type could insert to the capsid because of its legal size with the foreign DNA. But in non-recombinant type, it could not insert to the capsid because of its smaller size than the limitation of the capsid. So the size could be act as a selection marker in replacement vectors. We could not remove more of lambda phage DNA because the rest of DNA is necessary for rolling circle replication as expensive kind of replication. But the replication is important for us, not the type of it. So we replace the rolling circle system of replication with the plasmid replication system as a cheap system in terms of the size of necessary DNA. Through attaching a plasmid to coside and a recombinant DNA up to 40 kb, we have a new type of vector named cosmid. In cosmids, we can use the size as a selection marker too. Don't forget to like and subscribe.